First, let's go over these deficiency symptoms, but I want you to now look at those deficiency symptoms using the key that I provided, okay. So, do you have an extra copy here? Yeah, let me take this. So, I have provided a key. This is not in a good print, but I hope that you will be able to read it. But the key is kind of like very generalized, okay. Again, keep in mind, this is a good starting point. At least this will tell you what mineral element is likely deficient. But once you identify something is likely deficient, you should confirm with some laboratory analysis eventually. But this is like a quick key in your greenhouse, and you want to know what's going on, you can at least have a good idea about, oh, this is nutrient deficiency and this is most likely because of this particular nutrient. And then if we are really interested, we get a big vast infestation, deficiency, it may be a good idea to send a sample also to the laboratory, soil science laboratories or analysis laboratories, where they will actually tell you which elements are there and what is the percentage of different elements, okay. But this will help you as a key that you can keep with you in your greenhouses and then use this, in a real time basis, all right. Keep that in mind. And I've also kind of generalized this. This key is actually pretty complicated. It sometimes can be confusing. So what I did was I kind of generalized this key and sort of prepared a customized key for this class. So if you notice that I've divided, there are two boxes, right? One box is for the lower or older leaves, the other box is for the upper or younger leaves, okay? And then within each box you have further categorization. For example, for lower older leaves, there could be a generalized effect, which means it happens everywhere, or a localized effect, it happens only in particular part of the plant. And then within that also group you have all kinds of characteristics, like for example, leaves dark green and develop purple color, leaves are light green and yellow. So it's easy to, we can read it, you can understand it. But what I want you to do now is use this key, and for example, I have some pictures here, most of them you've already seen in the class, but now I want you to look at those pictures using this and see if you can identify what the deficiency is. But later on, after you practice this in the class, I want to take this key with you and I want you to go outside, look for plants, any plant is fine, see if you can, first of all, you can find any nutrient deficiency, then use the key, practice it and figure out what the deficiency is, and if you can, take that leaf and bring it. If you can't, if you don't want to pull that leaf or people are not happy, don't do that, take a picture of it and bring it, okay. But if you can, bring the leaf. But if you take a leaf and then walk around for another half an hour, that may wilt and may not be looking good. So photos is also okay, all right. But I want you to try to identify maybe 1-2 deficiencies using this key, just in the real world as you're walking, and then it doesn't have to be in a greenhouse, but any plant is okay, right. I do not know where your most of the plants are, but you probably know. If you are from this university, please guide others who are not and tell them where to go to find plants, crop plants or ornamental plants, so that way you can go around and look for these, okay. So let's start with this one. Use the key. I apologize, the key should be in color. You may be able to see it on your phones because they already sent it to you this morning, but that was not clear to me on the phone. Either way, whatever you like, but you can also use this one and see what is this deficiency. Yeah, but how, I know that it is nitrogen, but how do you get to that? What is the key? So you took the lower leaves, right, the top box, and then what did you do? So lower leaves, generalized effect, light green and yellow, right? You got to nitrogen. Okay, all right, good, easy, right? That's easy. Most of these are easy. This is meant for just like a refreshment for you from the class. The real situation is when you go outside. Okay. Ah. Okay, what about this one? How did you get to that? Somebody has to explain. So new leaves, growing point is alive, agree? and then chlorasis, light green to yellow leaves, brings you down to sulfur. It's kind of like a key, right? You can come down, right? Yeah, I know you're looking at the pictures that I've shown you before and then saying that, but go down, use the key. Use the key. There's a practice here, see? New leaves, upper new leaves, growing point dies, and then leaves, are these leaves twisted and die? No, they're not twisted, isn't it? They are just normally looking leaves. Leaves like have a hook like appearance, kind of, over there, turning like that. But the growing point dies. That's the key thing, right? Sometimes it can be confusing, okay? Yeah, but this is what? Upper new leaves. That's the difference, right? So he brings a good question. Where is potassium going on? Potassium, older leaves. But here you are seeing this as this top new, right, word. So that's the difference here. Okay. Now differentiating is important. Otherwise, when you go actually take it outside, it can be totally challenging. This is easy because I've shown you these pictures already. In your mind, you have an answer already, right? Okay, let's see. What is this? So is it younger leaf or older leaf? So upper new leaves, growing point is alive, and it is intervenal chlorasis. And then here is it can get a little bit confusing. Okay, you have sharp distinction between veins and chlorotic area, light distinction between veins and chlorotic area, and then you have middle leaves have intervenal chlorasis. Yes. So it could be either iron or manganese, and this is where a lot of people get really confused. What I'm trying to say is you sharp means clearly you can see everything in between is yellow and greens are clearly seen. Kind of light difference is like kind of it's not that clear but it's there. This is technically speaking manganese deficiency. Okay, this is light distinction, but it's confusing by the way. Keep in mind, this is where you kind of get into a situation where is it manganese or iron? Okay. So now I don't know what's going on, but now to add to another problem, huh? Right, right. I know what you're saying, but hold on. Let me pull this out first. Something came out here. It is sort of like an effect where it is it is little bit if you go all the way 10-15 feet you may not even see, you might see more like an yellowish color. uh, but I have an example again. How is magnesium different from any of these intervenal chlorasses? Go back. Magnesium appears in what? Older leaves. When it is being seen in the younger leaves, then it is either manganese or iron, and um, iron, it is a very sharp difference, and then for manganese, it's kind of like a dull difference. That's the kind of you can find something outside which kind of agrees more to what I'm saying here than this picture is, but this is manganese deficiency. I know that much. How about this one? So what are we seeing? We are seeing somewhat older leaves, right? It's a tomato plant, somewhat at the bottom. What are we seeing? Older leaves. Um, is this happening in a particular part of the leaf or in general the entire leaf? It's sort of like happening in all the leaves, right? All the leaves and also entire leaves, kind of like generalized in nature. And within that generalized effect, you have three things, right? Nitrogen, phosphorus, and molybdenum. What are we saying for nitrogen? Nitrogen leaves are all entire leaf is yellow. You don't see entire leaf yellow, so you can strike it off. Then molybdenum leaves light green with necrotic spots. Do you see any spots here? Necrotic spots, like spots, black spots. Do you see any spots? Yeah. So are you talking about this one? So, this one. Okay, so keep that in mind. So she said there are some spots. I'm not able to see spots there. Spot is like a black spot, brown spots, right? So I don't think I see that. But then look at phosphorus. Leaves dark green and develop. Oops, not that. Um, do you see? This is there is any purple color here? No. So our path has ended there, which means we did not come down right. Something went wrong. So what happens when you do wrong? You go all the way back again up. Okay. I'm just giving an example here where you can make a mistake. Okay. So now let's go back again. Is it again young leaf or old leaf? This is definitely, we know that it is old leaf. We tried a generalized effect. Now let's go to localized effect. Okay. On the localized effect, you have three symptoms: intervenal chlorosis, burning of leaf margins, necrotic spots. You see, you see intervenal chlorosis, but I'm also seeing the margins are burning. If it is intervenal chlorosis, you see here this area is green here. Do you agree what I'm saying? See, if I make this bigger, this area, there is a green lamina and green mean, so it is not intervenal chlorosis there. But what is happening, margins are kind of turning yellowish and they may turn brown later on and die. So it sounds more like a marginal necrosis there, which takes us to what? Potassium. See, this is actually potassium deficiency, earlier stages. The picture I've showed you in the class was again potassium deficiency of tomato at a later stages. But again, keep in mind, you may make mistakes, but whenever you make a mistake and you are done with all the options and you're not seeing an answer, go all the way to top again and come down again. So that's how, it's a trial and error method. It's a key, it's a trial and error method, okay? So this is a classical potassium deficiency with marginal chlorosis, which will eventually turn into necrosis. There is no intervenal chlorosis, although it is a little bit deceptive. It can confuse you. But look at the central area of the leaf. There is no intervenal chlorosis there. It's simply green in color. Just the margins are turning yellow in color. Okay. Now, to add to the confusion, you have a question? Yeah, go ahead. Yeah, I was about to say that. So in on a plant, you might find multiple symptoms, multiple nutrient deficient symptoms, and also you may find a nutrient deficient symptom and something else like a bacterial or a viral infection that looks like a nutrient deficient symptom. So you got to be able to differentiate that. Okay, it's not that easy, by the way. On this slide in this class, it looks very easy for you, but when you go outside, it's a different story. First of all, you may not find anything. So you got to really scout for them. But when you find, you have to ask yourself, is this bacterial, fungal, viral, or nutrient deficiency? Okay, it's nutrient deficiency. Then what? Old leaf, young leaf. Then what? So you got to use that. So it is sort of like a real world situation when you are outside. But here it is very easy. Okay. Okay, this is easy, right? Everybody can say calcium again, right? Blossom and rod of calcium. Now let's look through this through the key. So there is no young or old. It's just a growing tip, a fruit, right? It's a growing fruit. So I'm just saying leaves here. So it doesn't make sense. There is no leaf here, right? So in this case, you have to not even consider leaf, but go down one step down. Growing point is dying. That's the key thing here. All right, it's growing point, young growing point, whether it's leaf tissue or fruit, it's dying and it goes down straight to. There's no hook or anything, but it's a situation where there are no leaves here, and it is fruit, and that's blossom and rod. I just put it there to show you that sometimes this key may not be of big help to you, where you have to probably use your experience. Oh, I know this. This is blossom and rod. The key is only for what? Leaves, right? Uh, This is another example. I think I've shown this too, but you can look at it again. What is this? This is happening on the younger leaves, isn't it? So you see that this is kind of young leaves, right? The older leaves are at the bottom. Mostly the symptom is seen. Of course, here you can see both young and old, but it's appearing. It's at least appearing. You can see even the young leaves showing that completely here. So this one is a confusing one too. I just want to tell you that the key is there, but it is not like a silver bullet. You will end up into confusing situations where you may not know. You may say this may be manganese, you may say this may be magnesium, you may think that it is iron, but you don't know the exact answer. So how do you get to the answer? You take the sample and send it to laboratory. End of the day, confirmation has to happen there. But at least it will tell you that, oh, this is intervenal fluorosis, so it is a nutrient deficiency and definitely not a bacterial problem or a viral problem or a fungal problem. But in this particular case, it's petunia plants and there's iron deficiency in petunia. Okay. And the last one is pretty easy. I've shown you this. This is again phosphorus deficiency, right? So again, keep in mind this is just something you can use it as a starting point. It will take you to some level, advanced level, where you can say, I think it is most likely this symptom. But if you are in doubt, you should always go to a commercial laboratory and get this analysis. But if you are 100% sure, for example, let's say you send the samples to laboratory and they have confirmed it, and the next year the same thing happens, you are 100% sure, you don't have to really worry about laboratory anymore. You can change your fertilizer application to make sure that that particular nutrient is supplied to plants. So whatever time we have left now, almost we have 1 more hour. Do you want to go outside and scout for any nutrient deficiency, see if we can find something in the next 1 hour? Okay. And in the meantime, we're trying to do something this afternoon. Do you think we can? It's possible. Okay. 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 So we are trying to do something. We want to actually remember yesterday the table. In that table, we didn't have a substrate, so we are trying to take you to a place where we can actually do that in real world with a part and substrate, and then see how we can calculate that. But she's going to try and arrange that. If that happens, we'll probably spend an hour there and come back and do your quiz. Okay. If not, we'll do the quiz when we come back. But for now, I want you to take this, walk around, don't go too far away, don't get lost, come back, and then see if you can find at least one. More is good. See if you can find at least one. If you can't pull the leaf, take a picture and bring it to me. But come with an answer. You are going to show it to everybody and say why you decided that it is a specific element. You may get an answer from others that it is not, it may be different, but you have to judge and support your assessment. Okay. All right. Take these papers with you. I'm not coming with you. I'll be here. All right. But you come back. But we all meet before lunch. All right, at least 10 minutes before lunch, so we can at least talk about it. Yeah, 12. Just show the leaf and explain. You could be right, you could be wrong. I may not know the answer, but at least I want to see if you are making an attempt using that key to kind of diagnose. Okay, so let's see. Who wants to stand up and show and then explain why it is what it is? Who wants to go first? You want to go first? Okay. So for nitrogen deficiency, we need to see where it is from, right? You pull the leaf, but was it at the bottom or at the top? Was it the top or was it the bottom? Okay. So it's easy. So you pick the easiest one. Okay. So do you agree? All of you agree for that nitrogen deficiency? He says it's lower leaf and it is kind of turning yellow, right? Nitrogen deficiency. All right. That's something you can never miss, right? Nitrogen deficiency. You can easily see. All nitrogen deficiency. So you also have nitrogen deficiency. Okay.
This one is comparatively less darker than all the leaves.
Huh.
So it was also appearing as if, is it, there might be two reasons. One, it might be a new leaf, or otherwise it
we cannot say, right? It's too early to say anything. It could be new leaf or I don't see any yellowing there. Okay. What else do you have?
Sir, this
is caladiums, right? Yeah, that's caladium. But that's natural variegation. We had something like that.
yes, sir.
Yeah, parts outside.
Generally, they are darker
Well,
color.
there are a lot of variegated caladiums too, so I wouldn't get to that.
Sir, it has scorching on the margins.
Okay, this could be some deficiency.
And also there are yellowing near.
That's what yeah. It's not a leaf spot or something like a fungal leaf spot. It's definitely some scorching, marginal necrosis. So could be potassium. Yeah, yellowing. That yellow is just starting to become brown, and then eventually it becomes brown.
This is turning to necrosis.
Okay, what else you have?
So this one is
That's disease, right? That's leaf spot, cercospora or some leaf spot. Okay.
so this is chloride again.
I don't know what is it then, in your opinion?
So it is nitrogen deficiency.
Okay, nitrogen. So you're all finding nitrogen deficiencies. Okay, we'll come there. We'll come to you. Let's finish. So this is what? This is possible marginal necrosis. Okay, all right. I suspect this is probably fungal. I suspect. See, well, one thing I want to tell you. Remember, so this is very classic. You see circular. That could be either fungal or what viral. I don't know. But bottom line, for bacterial, you can see this. Bacteria cannot cross veins. Okay, so bacteria infects the leaf lamina, and the infection is spreading. But the moment that infection hits the veins, it won't be able to cross the veins. Because of that, the bacterial symptoms, they look angular spots on the leaves. That's kind of bacteria. This is more concentric circles. You can see the circle inside, circle inside, circle inside. That's more either fungal or viral. Most likely fungal though.
This looks like an intervenous fluorosis, and this might be
Possible. Yeah, that's intervenous fluorosis. Clearly intervenous fluorosis. It cannot, because its vein is an obstruction. It's a hard, solid structure. So it has to cut through. It takes some. So what bacteria basically does is, rather than putting all its energy going through that vein, it spreads downwards or sideways. So wherever the veins are, kind of veins become the margins. So the kind of, you see angular kind of discoloration because of that.
I think it is boron deficiency because this is the leaf of hibiscus.
Okay.
It was new
You see spots, right?
Yes, chlorotic spots on growing point is alive, and there is chlorosis, but light green to yellow leaf. I can't see such. I can see chlorotic spots.
Yeah. So this could be a boron deficiency. I think this is something you all want to see. This, you see the chlorotic spots here, chlorotic spots, and why don't you explain to everybody why you think it is boron, but you say it louder so everybody can hear.
The leaf of hibiscus plant, and this is a new leaf, and the growing point is alive, and we can see the symptoms of chlorosis. The green color is fading away from the leaf, but there is no green or yellow pattern. Basically, these are spots, chlorotic spots on the leaves. So this can be deficiency of copper. Sorry,
Copper.
it is not boron. It is copper deficiency.
Yeah, micronutrient deficiency. So, but you at least know that it's a micronutrient deficiency. You know that it's a deficiency. You know it's most likely a micronutrient deficiency. So at this stage, what you can do is either you can send the sample for analysis, or you can apply micronutrients to plants. Right? They sell micronutrients, like Micromax is a fertilizer they sell that you can apply, and if the deficiency goes away, your problem is solved. Right? That's the advantage. Who else has something different? You took a picture here.
excessive water.
I cannot say, unfortunately, it's too difficult for me. What is it, first of all?
So it was a lower leaf.
It could be water, it could be drying, it could be senescence. We don't know anything like that, right?
So this leaf has chlorosis, but some green spots are visible.
Yeah, but it's probably nitrogen if it's turning nitrogen. Yeah, if it is older leaves are at the bottom, if that's what you see. What did you see?
So it could be sulfur as
Yeah, possible.
yellowing is
Common. And it's happening at the top of the. Okay. Yeah, it could be sulfur. You see, now you're able to actually, come at least to some level of conclusions, right? You may be right, sometimes we may be wrong too, but at least now we know certain things are very easy to determine. We'll definitely get it. But some things may be a little bit confusing. Okay. What did you find, you guys at the back? I don't know if that could be fungi too, right? Sclerotia or something like that.
But there is a localized effect on burning.
Usually you see a lot of yellowing or blackening or yellow spots to call it as a nutrient deficiency. I don't think it is a nutrient deficiency though. I don't think so, but that's me. Yeah.
I think so. You have
Okay. You should send it to a laboratory. Or anything over there. What did you find? Some edges. Again, keep in mind, often you will see something like this, right? Along the edges, you'll see death are there, edges. I don't want you to get confused. Potassium is one thing, but what we also know is that if the air is too dry, it can cause that. But in this area, air is never dry, isn't it? It's humid always. So probably it's not related to dryness of the air. Yeah, something like this. Yes. But it could also be due to excess fertilizer sometimes, right? But in this case, probably they haven't applied excess fertilizer. So you have to apply some common sense on top. There is a response, but you also need to apply some common sense. Most likely this is potassium, but again keep in mind the marginal necrosis can be due to dry weather or can be due to really excess fertilizer in the pot or something like that. But if that is those two things are not the case, most likely it is potassium. Okay.
intervenous space, it's green, but venous space is yellow. So it is kind of opposite. So
Is this like all the leaves are like this, or just one a few leaves?
some leaves, lot of leaves, but
But most of the leaves are pure green then.
yeah.
Huh.
In fact, he also has one. So I can get it. Some veins are yellow.
So one possible. So you have seen this. This one is not intervenous fluorescence. The veins are yellow actually. In between veins, it is still green in color. Something similar here too. And one thing I suspect is that this is probably the starting point, and the entire leaf might turn yellow very soon. Is this at the bottom of the leaves mostly? Do you know? Like sometimes the leaves get old, they senesce, and when they're senescing, but it's not senescence. It is very interesting. I don't know what this is, to be honest with you. I've never seen it may not be nutrient deficiency at all, because the veins are kind of turning yellow.
Is it due to
Water limitation, but here I can see this may be turning into some completely yellow in color with time. But here it is very, very, I don't know. I don't know the answer for this. Okay. What did you find? Somewhat leaf necrosis and yellowing again. Some either could be potassium or dryness of the atmosphere or excess fertilizers. Okay.
This is simply it was from lower leaves.
Yeah, this is kind of yellowing, nitrogen going down. Yeah. So it all looks.
From middle leaves, younger leaves.
Yeah.
Might be some
And this is not young leaf?
young leaves. These are young leaves.
So they may be turning green later. Maybe they start like that. Possible, right?
And this one is from same area.
Yeah. This is young leaf.
Nearby leaves are the trees. Both leaves are black.
This is not intravenous process. Or maybe it is. Are the veins green and in between is yellow? Light, maybe some micronutrient for sure, manganese or something like that. Some spot. Are there? So anything new? Did you find something? This is not a genetic thing, right? Are all the leaves like that? Just some.
Also have
This is not a variegated variety, right? Some leaves are very.
Actually, that plant had two types of. I also witnessed that plant. It had one darker color leaves and other one trees green.
That could be simply some genetic thing then. I mean, this could be simply genetic rather than a nutrient deficiency. Chimeras are sometimes you'll see some plant leaves are different while other side of the leaves are green in color.
What might be the reason for this? Don't say
This is dryness basically. The tip drying down. Again, on a leaf, remember the portion here, the tip. This is where the most resistance is there for water flow. So water is flowing from roots into stem, right, into petiole, then into leaves, main vein, and then into other smaller veins, and then eventually to the edges, right? So the most resistance for water is right here. There is a lot of water here, relatively more water here, then more water here than here. But when you get to this point, there is relatively less water because the water has to flow all the way to the edges. So if you only see some burning happening on the edges like this, that's mostly drought.
Sir, it might be due to improper watering of the
Possible.
plants.
Possible. Drought. Yeah. Anything different? Did you find anything interesting? Some pictures? You have something? That could be genetic. That could be genetic, not nutrient deficiencies. It's just they showed me some leaves too like that, where some leaves are different other leaves, but it looks like not deficiency, because the deficiency doesn't happen on one side and not on the other. It kind of happens everywhere, generally speaking. This is this old leaf like falling off, like it is senescing, like old leaves become yellow and then they fall off. I don't know if even this is a nutrient deficiency. I don't know either of these are nutrient deficiencies. Oh, that purple. Yeah, I see it. What I do not know is if that leaves, sometimes they are genetically they turn red in color. Sometimes in the fall the leaves kind of turn. So that red could be simply the anthocyanin. So remember in fall colors. Do you know fall colors? Yeah, maybe in this area in the fall the leaves will turn all kinds of colors, right? Red color. That could be, the red color is because what happens is chlorophyll completely goes away. That's genetics. Then the red color shows up. So I suspect this is more anthocyanin that's just showing up in that leaf.
This might be possible that in the later stages, this color will also turn to the remaining leaves. This remaining leaf will be like this other half.
He has already an example right there. Yeah,
Because it is extending towards that. So it might be the genetic factor.
possible. I'm not seeing a nutrient deficiency there, like chlorosis or anything like that. That's what it is. You took some pictures too. This is ficus, right? I'm pretty sure this is genetics. I've seen this variegated ficus. This is what you grow, rubber plants, right? You grow in the houses. This could be deficiency. This could be nitrogen. Old lower leaves turning off. This could that yellowing, and the same plant, right? That's the same plant. That yellow leaves could be deficient. That could be the nitrogen deficiency. Bottom part of the leaves.
So the rest might be the story that initially the leaves are green, then they are transforming to the color.
I don't know. Those holes are beetles, insects. Generally, beetles make the holes. Insects, right? That's insect for sure. So, what did you find? Yeah, intravenous chlorosis, and it's at the top of the plant.
It was around, it was in the top also and in the lower side also.
So, what do you think then? Likely manganese. Yeah. Also, it's not sharp, right? It's kind of dull intravenous chlorosis. Yeah, could be manganese. Yeah, yeah, that's a good find. So some of you are finding stuff, but some of you are also finding like this that I can't even know. Uh, it's confusing me, but it's not definitely nutrient deficiency. It's something else. I'll see if I can find something about it, but you can also Google out. This is definitely intravenous chlorosis, right? Yeah, here is another example. So now let's do this. I think I cover everybody? Did I miss anybody?
This is the same plant.
Yeah, so let's do this. Let's take one example. So you also bring your example. Let's put it here so everybody can see what we find. So this is internal cross. You got nitrogen deficiency. I saw somebody showing potassium deficiency. So let's take that. What else do you have? What is that?
Variety is
Possible phosphorus then. Yeah, you can take that one, copper. We found this one. That's correct. That's sulfur. So would have been nice. I'm just putting things so everybody can see. Yeah, what else? Anything distinct? I don't want this. This is genetic. Um, t- yeah, we thought this is yeah, yeah, something like that. I found it, but I want to look at. I think this is more of a potassium. Yeah. Okay, so these are the samples I have. Is there anything you showed me something nitrogen, right? You showed me some. It's nitrogen. It's nitrogen. Okay, I think I have the nitrogen deficiency there. So those are the things we found. What is this one? Yeah, it's more like dryness, drying out leaves. Okay, what else do you have?
Can this be the deficiency of molybdenum because leaves light green with necrotic spots?
But this also could be simply anything like a sulfur and nitrous. The yellowing is the more important, dominant part. That yellowing, an advanced stage, becoming necrotic. But this is kind of becoming yellow more like chlorosis rather than necrosis to me. The initial symptoms of chlorosis could be something else.
So then how can we differentiate? Sometimes we see this burning symptom in blight,
Right?
and as well as we can see many deficiency have
Yeah,
burning
that is a
symptom.
challenge. And only by experience. Only by experience. The more you work on blight and you know this is exactly blight, this is not blight, like that. So there are a lot of things that overlap. It's this the challenge. That's the challenge. Again, my goal today is to at least get you to a stage where okay, where yeah, yeah, we have to leave, right? 1:15. Yes, I'm ready also. But I got some samples here in case if you want to see. I have some chlorosis. I have some copper deficiency from him. I have intravenous chlorosis. And then there is some necrosis also, potassium deficiency here. And some of you showed me pictures. Nitrogen deficiency is there because several of you showed me that. So I hope that key is something you can keep with you and kind of practice that. Today you got a little bit forward, but keep on using it. And whenever you see something, I think you can probably take a picture and have it in your phone, so you don't have to carry the paper. But maybe practice that. That might help you. Okay. Um, Again, like I said, this is just one step, and in order to confirm, you have to go to the a laboratory to get that information. Okay. All right. Sounds good. So she has to tell me she went there to do that. We'll see. If not, okay. So well, let's convene here. How far it is from here? Okay. So let's convene here at 3 o'clock and let's plan at the time. Whether we do the quiz first and then go to lab, or should we go to lab first? So we'll go to the lab from here. And so what I'm trying to tell you is yesterday we did a table, isn't it? In that table, I just gave you some numbers and we plugged in but I'm trying to actually do that laboratory activity with actual substrate, so you'll get more experience, and I think he's arranging for that. So let's convene here and then let's walk there. Let's finish that. Okay, let's do that first, and let's see how much time we have. Don't worry about quiz. Anyway I'll have a 100 question exam for you towards the end. So would you mind? Can you please throw these things out, all of them? Yeah, let's keep the tables clean. Let's throw them away in a trash can properly.
The majority of plants are nitrogen deficient only.
Yeah, because that's easy to find, so we'll find it easily. But if you keep on scouting, you may find it. And when you find it, you can probably take a picture or store it, save it.